Something huge just happened in the sky above our oceans, and it happened in the last 24 hours. Right now, two of the biggest weather makers on planet Earth are locking together for the first time in years, and the result could flip winter upside down for hundreds of millions of people. We are talking about a super El Nino that is already on pace to be one of the strongest ever measured, now joining hands with a second separate ocean event happening 7,000 miles away in the Indian Ocean. When these two forces sync up, they do not just add together. They create something scientists are calling a dual ocean engine, and it is strong enough to bend the jet stream across the whole Northern Hemisphere. This is not some far off maybe. It is already showing up in the weather pattern this month, and it is expected to grow into something much bigger by fall, then explode into a winter that could look nothing like what most of North America and Europe has seen in years. So who gets the mild winter, and who gets slammed with cold, ice, and flooding rain? Which regions could see snow piling up in places that almost never get it? And why are scientists saying their own computer models might actually be underestimating how strong this could get? Stick with us, because we are going to walk through everything step by step, using the real forecast data and the real science, no exaggeration needed. Before we dive in, this kind of research takes a lot of digging through models and data, so if you find this helpful, hitting like and subscribing genuinely helps us keep making these deep dives, and it costs you nothing. Now let us get into what is actually going on. Let us start with what is happening right now, in the middle of August, before we jump into the bigger, scarier picture. If you have been following the story of this super El Nino as it built up over the summer, you already know the ocean in the tropical Pacific has been heating up fast. As of this week, the surface of the ocean in the key watch zone is running about 4 to 5 degrees Celsius above normal. That alone is a big number. But the real engine underneath all of it is something called a Kelvin wave, a massive underwater pool of warm water sitting in the top 500 meters of the ocean. And right now, its core is measuring more than 8 degrees above normal. That is an extraordinary number for anyone who tracks ocean heat. Forecast models from the United States Climate Prediction Center and the European Weather Model, known as ECMWF, are now projecting this event could push past a 3-degree surface temperature anomaly at its peak. If that number holds up, this would rank as one of the strongest El Nino events ever recorded in modern history. Here is why that matters beyond just being a big number on a chart. That extra ocean heat does not just sit there quietly. It reaches up and reshapes the entire atmosphere above it through something called the Walker circulation. Think of the Walker circulation as one giant loop of air that rises in one place, travels across the sky, and sinks back down somewhere else, stretching all the way across the tropical Pacific and Indian Ocean. As the ocean warms up in the central and eastern Pacific, air rises there more forcefully than usual, and that same air comes back down over the Indian Ocean instead. This shift in where air goes up and where it comes down does not stay near the equator. It ripples outward like a stone dropped in a pond, reshaping pressure patterns and jet stream behavior thousands of miles away, all the way up into the areas where most of us actually live our daily lives. Meteorologists are already watching this signal show up directly in this month's weather pattern. There is something called an atmospheric standing wave, which is basically a fixed zone of rising air and low pressure that gets locked in place by the strength of this El Nino. Through the first half of August, that translates into a ridge of high pressure building over the west central United States and Canada, which pushes warmer temperatures into that part of the continent. At the same time, there is a separate signal trending toward a swing back the other way by the middle of the month, with a stronger area of low pressure developing over the eastern United States. That could bring a real, if temporary, cool down to that region, even in the peak of summer heat. By late August, forecasters expect the pattern to shift again into what is becoming the signature setup for this El Nino, a ridge sitting over the west central United States and Canada, paired with a trough, and near to below normal temperatures settling into the eastern half of the continent. Now here comes the actual breaking news part of this story. Just this week, meteorologists confirmed the emergence of a second major tropical ocean event, something called a positive Indian Ocean Dipole, forming thousands of miles away from the Pacific Ocean, but now beginning to link up with El Nino's grip on the global atmosphere. If you have never heard of the Indian Ocean Dipole before, here is the simple version. It works on almost the exact same basic idea as El Nino, just happening across a totally different ocean. Under normal conditions, water temperatures across the Indian Ocean sit fairly balanced between its eastern half and its western half, but during a positive Indian Ocean Dipole event, the trade winds shift in a way that cools the eastern Indian Ocean near Indonesia, while warming up the western Indian Ocean near the coast of Africa. That temperature difference between the two sides, the dipole, creates its own local version of the exact same rising air and sinking air pattern that El Nino creates in the Pacific, just centered over a completely different stretch of ocean. On its own, a single positive Indian Ocean Dipole event usually only creates a modest ripple in the broader jet stream. It shows up in seasonal weather data, but it is not usually strong enough to reshape weather patterns thousands of miles away all by itself. So what actually makes this moment so significant is the timing. The latest ocean analysis confirms that this positive Indian Ocean Dipole phase is developing at the exact same time as, and is mechanically connected to, the very same weakening trade wind pattern that is fueling this year's super El Nino in the first place. In a real sense, both of these ocean events are two symptoms of the same larger shift happening in the tropical atmosphere right now. Forecast models currently expect this positive Indian Ocean Dipole phase to stick around through fall and into early winter, meaning this is not just a short blip that fades away in a few weeks. It is shaping up to be a sustained event running right alongside El Nino's own peak strength later this year. The last time forecasters saw a comparably strong positive Indian Ocean Dipole pair up with an El Nino event, this significant was back in the winter of 2023 and 2024. Now here's the part of the story that actually explains why everything is about to change, and it is worth understanding how it works rather than just taking it on faith. When two separate tropical ocean systems both build strong zones of rising air at roughly the same time, in this case one over the central and eastern Pacific caused by El Nino, and one over the western Indian Ocean caused by the positive Indian Ocean Dipole, they end up sharing a zone of sinking air anchored over Indonesia that connects the two together. Meteorologists describe this as a combined or dual ocean forcing pattern. Research on this exact combination has found that these two systems do not simply add their effects together in a simple, straightforward way. Instead, that sinking air anchored between them over Indonesia acts almost like a fixed pivot point, locking the broader atmospheric circulation into place more firmly and for longer than either single event could manage alone. The combined tropical heat and rainfall signal then launches what scientists call an atmospheric wave train. Picture it as a chain reaction of alternating high pressure and low pressure systems that spreads outward from the tropics all the way up through the middle latitudes, reshaping the jet stream across the entire Northern Hemisphere as it travels. There is a genuinely striking detail buried in the latest research that is worth sharing here, because it is a good reminder of how these kinds of forecasts should be read and understood. When scientists compared what their computer models predicted the wave pattern would look like against what actually happened in the real atmosphere during past winters that combined El Nino with a positive Indian Ocean Dipole, the real-world data showed a noticeably stronger response than the models had predicted. In plain terms, actual winter storm systems appear to feed off this combined tropical energy more aggressively than the models account for. That suggests the atmospheric pattern locks into place faster and more firmly once winter actually arrives than a purely model-based forecast might lead you to expect. As we move through autumn, the forecast signal coming from this combined Pacific and Indian Ocean forcing becomes clearer and clearer across North America. The core of the warmest temperature anomalies is expected to sit over the northern half of the United States and across Canada, tracking underneath that same persistent ridge of high pressure we talked about earlier. Meanwhile, a more active and wetter storm track is expected to set up across the southern half of the country, driven by an increasingly amplified Pacific jet stream. That will keep temperatures closer to normal across the south, even as rainfall totals climb well above average there, especially across the southern states. Over in Europe, the fall outlook shows a genuinely different character compared to what is happening in the United States. Warmer than normal surface temperatures are expected across much of the continent, especially in Central and Western Europe, driven by a persistent westerly and southwesterly flow that keeps pulling in mild air from the south. Rainfall is expected to run above normal across most of the continent outside of the far north, as that same low-pressure influence from the Atlantic keeps pulling in repeated waves of moisture from the west. This is where the forecast becomes genuinely important for tens of millions of people, and it is worth walking through it region by region, while also being upfront that we are talking about a seasonal outlook that is still several months out, not a locked-in forecast for any specific storm or date. Across North America, the dominant setup taking shape is something meteorologists are calling a split flow pattern. Picture a strong, persistent blocking ridge of high pressure anchored over Canada, paired with a deep, highly active low-pressure zone stretching all the way from the North Pacific across the central, southern, and eastern United States. That high-pressure block sitting over Canada acts almost like a boulder sitting in the middle of a stream, deflecting the flow of cold Arctic air and generally keeping it bottled up to the north, rather than letting it plunge as deep into the United States as it might during an average winter. For the northern tier of the country, meaning Canada, the northern plains, the upper Midwest, and the Pacific Northwest, that setup translates into a milder than normal winter overall, with reduced chances of the deep, sustained cold outbreaks those regions sometimes experience, and correspondingly lower snowfall potential across the northern Great Lakes and the Pacific Northwest specifically. For the southern half of the country, though, the outlook flips entirely, with that active, moisture-loaded storm track running persistently across the central, southern, and eastern United States. Forecasters expect below normal temperatures across Texas, the Gulf Coast, and the Southeast for significant stretches of the season. That is driven by repeated intrusions of cooler air riding along the active southern jet stream, combined with persistent cloud cover and rain. That same moisture, rich southern storm track, whenever it manages to tap into cold air, creates real potential for winter storms and ice events reaching further south and east than usual, with elevated snowfall potential currently showing up across the Southwest, the Central Plains, parts of the Midwest, and stretching into the mid-Atlantic and interior Northeast. This is a genuinely different setup compared to a typical winter, where the biggest snow totals usually pile up much further north. By the heart of winter, meaning January and February, the forecast models actually show this pattern intensifying rather than weakening. There's an even deeper pressure trough developing across the country and a sharper divide in temperatures from north to south. Continued mild conditions stay locked in across Canada and the northern United States, while an expanding zone of below normal temperatures spreads across the entire southern half of the country, as cold air intrusions riding in on that active storm track become more frequent, even without a true, sustained Arctic outbreak reaching that far south on its own. Europe's winter picture, shaped by that same combined tropical forcing arriving downstream, points toward an amplified westerly flow coming off the Atlantic, with a low-pressure zone parked over the northwest, and a ridge of higher pressure extending up from the south. That setup favors an overall milder, wetter winter for much of the continent, driven by that persistent mild Atlantic flow, though it still leaves room for the United Kingdom, and Ireland specifically, to see periodic colder, more northerly intrusions, whenever low-pressure systems track further north than average. Meaningful, widespread snowfall across most of the continent looks less likely under this setup, with the best chances instead concentrated across the far north, the northeast, and higher central European elevations, where individual storm systems dropping further south than the broader pattern favors could still deliver real snow events, even in an otherwise mild season overall. It is worth being direct about the limits of a forecast running this far out, because that is exactly the kind of honesty that separates a genuinely useful seasonal outlook from empty hype, designed just to grab attention. Everything described here for fall and winter comes from seasonal forecast models, which are tools that are genuinely skillful at capturing large-scale, month-long tendencies, especially when there is a strong, well-understood driver behind them, like a super El Nino paired with a positive Indian Ocean Dipole. But these models are not, and were never designed to be, a forecast for any specific storm on any specific date. The broad shape of the pattern, mild in the north, stormy and cooler in the south, is a real, well-supported signal at this point in time. But exactly which week a given ice storm hits the mid-Atlantic, or how many total snow events any one city ends up seeing, remains genuinely unknowable this far in advance, no matter how good the models are. Meteorologists tracking this pattern have also been very clear that they are watching the data update on a roughly weekly basis, as summer turns into fall, because a forecast built on a still-developing ocean anomaly, and remember, this positive Indian Ocean Dipole only just crossed into an active phase this very week, can and does keep evolving as more data comes in over time. That said, the overall direction of this pattern has been remarkably consistent across multiple independent forecasting agencies for weeks now, and that consistency is exactly why confidence in the big picture is genuinely higher than usual for a forecast reaching this far into the future. But genuinely higher confidence is still not the same thing as absolute certainty. And it is worth holding on to both of those ideas at the very same time as we move forward through the rest of this year. None of this requires any dramatic action today, but a forecast carrying this much lead time and backed by this much agreement across different models is genuinely useful for planning ahead, rather than simply reacting after the fact once the cold or the storms actually arrive. If you live across the northern tier of the United States or in Canada, a milder, lower snowfall winter overall is good news for your heating costs and for winter travel, though it is still worth keeping standard winter preparedness on hand, since even a mild leaning season still includes real variability from week to week. If you are anywhere across the South, meaning the Gulf Coast, Texas, or the Southeast, this outlook is worth taking seriously well before winter actually arrives. A wetter, more active, and occasionally colder pattern than these regions typically experience is worth factoring into everything from holiday travel planning to checking that your home is actually equipped for an occasional hard freeze, things like insulated pipes, a working heating system, and a basic plan in case of a rare ice event, since infrastructure across much of the South simply is not built for frequent winter storms the way infrastructure across the North tends to be. If you are in the Central Plains, the Midwest, or the Mid-Atlantic, this looks like a winter worth watching closely for snow and ice potential specifically, given how the storm track is currently projected to set up over the coming months. And if you are in Europe, particularly in the United Kingdom or Ireland, keep a close eye on the periodic colder snaps that this pattern still allows for, even inside what is otherwise shaping up to be a milder, wetter season overall. This is genuinely one of the more significant seasonal weather stories developing anywhere in the world right now. Two major ocean systems are syncing up at the exact same time, feeding into a jet stream pattern that is already showing up in this month's forecast, and one that is projected to strengthen straight through fall and into a winter that looks meaningfully different from a typical year across huge parts of North America and Europe. Let us take a step back for a moment and really appreciate how rare it is for two ocean systems this large to line up this cleanly at the same time. The Pacific Ocean covers roughly a third of the entire surface of our planet, and the Indian Ocean, while smaller, is still enormous, stretching from the coast of Africa all the way to Australia. For heat anomalies in both of these oceans to develop at the same time, and for them to be mechanically linked through the very same weakening trade wind pattern rather than just coincidentally overlapping, is the kind of setup that meteorologists only see a handful of times each decade. That is part of why so many scientists are paying such close attention to this particular combination right now, rather than treating it as just another routine seasonal update that comes and goes without much notice. It also helps to understand why the Indonesia region keeps coming up again and again in this story. Indonesia sits almost exactly at the crossroads between the Pacific Ocean and the Indian Ocean, which means it ends up sitting directly underneath that shared zone of sinking air we talked about earlier. The zone created when both El Nino and the positive Indian Ocean Dipole push their rising air zones toward each other from opposite directions. When sinking air sits in one place for a long stretch of time, it tends to suppress rainfall directly underneath it, while reinforcing rising air, and therefore wetter conditions, in the zones on either side of it. That is part of the mechanism driving the wetter conditions expected across the southern United States and much of Europe this fall and winter, since both of those regions sit downstream of that same locked-in tropical circulation pattern that keeps feeding energy into the jet stream above them. Something else worth understanding is why scientists keep emphasizing the strength of this El Nino specifically, rather than just calling it a normal El Nino year like any other. Not every El Nino event behaves the same way. Weak or moderate El Nino events can sometimes get overwhelmed by other, more local weather patterns, meaning their influence on the jet stream ends up being subtle or even hard to detect in some seasons. But a super El Nino, meaning one strong enough to push sea surface temperatures more than 2 degrees Celsius above normal at its peak, tends to overpower those smaller, more local influences, which is exactly why forecasters are so much more confident in the broad shape of this outlook than they would be during a weaker or more ambiguous year. Pair that kind of strength with a positive Indian Ocean Dipole reinforcing it from a completely different ocean basin, and you get a signal that is about as clear as seasonal forecasting ever gets. This many months out from the actual season, it is describing. Let us also talk for a moment about what this pattern means beyond just temperature and snow totals, because a pattern like this touches far more than just what the thermometer reads outside your window on any given day. An active, moisture-rich storm track across the southern United States means an elevated risk of flooding rainfall in places that are not always built to handle it, particularly across parts of Texas, the Gulf Coast, and the Southeast, where soil and drainage systems can struggle to keep up when storm after storm rolls through in a short window of time. On the flip side, a milder, drier pattern locked in across the northern tier of the country could ease some drought concerns in spots that have been running dry, while also meaning lower heating demand and potentially lower energy costs for households and businesses across that region through the winter months ahead. These are the kinds of practical, real-world ripple effects that come from a big picture pattern shift like the one we are describing here today, effects that reach well beyond the weather itself and into everyday life for millions of people. It is also worth noting how this pattern could interact with the return of colder air at various points throughout the season, even in regions expected to run generally mild for most of the winter. A blocking ridge parked over Canada does not mean cold air disappears completely from the picture entirely. It means that cold air gets funneled and redirected rather than plunging straight south the way it might during a more typical winter pattern. That redirected cold air still has to go somewhere, and in this kind of pattern, it often ends up riding along the edges of that active southern storm track, which is part of why forecasters are highlighting the potential for ice events and cold air intrusions reaching further south and east than usual, even in a winter that is expected to run mild across much of the northern half of the continent overall for most of the season. As for Europe, it is worth remembering that a milder, wetter pattern does not mean a completely snow-free or storm-free winter for the continent as a whole. It means the balance of probabilities shifts toward more Atlantic influence and fewer of the deep, cold continental air masses that sometimes dominate European winters in other years when the pattern sets up differently. The United Kingdom and Ireland, sitting right at the edge of that Atlantic influence, remain in a position where a shift in the exact track of the jet stream, even a relatively small one, could still bring in occasional colder, more northerly air, which is why forecasters are careful to flag that possibility, even while describing the overall season as leaning mild and wet for the continent as a whole this year. Bringing this all together, what we are really looking at is a rare alignment of two of the most powerful natural climate drivers on the entire planet, syncing up at nearly the same time, reinforcing each other rather than canceling each other out, and sending a signal through the atmosphere that is already visible in this month's weather pattern, and expected to grow stronger and clearer as we move through fall and into the heart of winter. The northern half of North America looks to be heading toward a milder, lower snowfall season overall, with reduced odds of deep Arctic outbreaks. The southern half looks to be heading toward a wetter, stormier, and at times colder season than these regions typically experience, with real potential for ice and snow reaching further south than usual. Europe looks to be heading toward an overall milder and wetter winter, driven by a stronger flow of air off the Atlantic, while still leaving room for occasional colder snaps, particularly across the United Kingdom and Ireland when the jet stream dips further north than average. We will be tracking every single update to this forecast as new data comes in over the coming weeks, especially as that positive Indian Ocean Dipole continues developing, and as the Super El Nino works its way toward its peak intensity later this year. Given everything we just walked through together, does this match what you were already expecting for your winter this year, or has this changed the way you're thinking about the months ahead? Drop a comment and let us know what your summer has actually looked like where you live, because we want to compare notes on what the ground truth has been against what these forecast models have been projecting all along. And if you want to keep tracking this story as it develops week by week, subscribing really does help make sure you do not miss the next update, and it costs nothing to do. We put a lot of hours into pulling this data together from multiple independent forecasting agencies, so if this breakdown helped you understand what is coming, tapping that like button genuinely helps this reach more people who need to see it before winter actually arrives. Let us see if we can get this one to 5,000 likes. Thanks for watching. Stay safe out there as this pattern continues to develop, and we will see you in the next one.